Greetings and welcome, friends. Amigos, math fans of all ages, fans, maybe you're just here, you clicked on this video because you're like, I like shapes. And welcome. Today we're talking about congruent figures. So it says here, identify all pairs, so pairs means two, of congruent corresponding parts. And so I was told that these two polygons, looks like they're quadrilaterals. I don't think they're trapezoids, but they might be. And I was told that they're both congruent. So let's start with labeling the angles. Angle G is congruent to angle, and even without looking at the picture, notice G was in the first slot, so Q is the one that matches it because it's in the first slot. Angle H is congruent to angle R. Angle J is congruent to angle S. And angle K is congruent to angle T. Right? So I'm just matching slot for slot, but notice that I also could have determined that based off of the picture. So S had 4 arcies, and J also had 4 arc marks. Now, as far as side lengths go, I think let's figure out GK Chesterton right here is going to be congruent to, I would assume it's this short one over here, but just to verify, G and K were the first and last letters in the name, and Q and T are the first and last letters in that name. So I'm going to say QT right there. Bam. And let's see, GH, right, is going to be congruent to, well, GH and QR, yeah. And it looks like that's the case. It looks like this is just a rotation of the other one, really, which if you want to, once you figure out what transformation would get one to the other, it's sometimes visually easier to match up what is congruent. HJ is congruent to the SRRS. Those are the same. There we go. And the last one, right there. Thing of beauty. So yeah, so this is just an exercise in recognizing the corresponding parts of congruent figures. If the figures are congruent, all of their corresponding parts are congruent. If all of the corresponding parts are congruent, then the figures are also congruent. I don't know. My favorite professor was Australian, and actually he travels the world and has an international math handshake, but I don't know how international it really is. So let's see, here we go. I'm told these two figures are congruent. Let's be careful here. Measure of angle Y is going to equal what? Yeah, it matches up Y to N, and so it's equal to the measure of angle N, which, yes, is 124. So you could have written measure angle N or 124, but I think in this case they were looking for the number. Measure of angle M, right here. Yeah, corresponds to X. There we go. And yeah, corresponds to X. So I could have said measure angle X, which is equal to 33 degrees. Right, it's equal to a whole bunch of things right there. Measure angle Z corresponds to this one over here. And how did you find that? Yeah, so I know by trisum, all 3 of those interior angles add up to hundo ete. So I could have said measure of angle Z plus, my apology, 33 plus 124 equals hundo ete. Combine like terms, measure angle Z plus, they do say Z in Great Britain and Australia, I believe, right? And Canada? Did not know that. That's the name of the letter, I guess. 33 plus 124, 155. And subtract that 155 from both sides. Measure angle Z looks like it's, oh, I almost wrote 35. I think it's 25, isn't it? Oh, Waddy error. Thank you for the save. So here we go. So this was 157. Thank you. And so 23 degrees equal sign right there. What was the question over there? Oh, yeah, that happens. So you can't trust everything a teacher says. You gotta think for yourselves, friends. And xy right here is xy. That's going to be congruent. Well, xy are the first two letters here, so mn. So it's equal to mn. Notice it didn't have the hat above it, so it wasn't referring to the object. It was referring to a number that represented its distance, and that's also why it's using equality. And mn is ocho, so I also could have said 8, which is probably the answer they were looking. Internet friends, I just had a question. What's the movie with the owls? Comment below. There you go. All right. Here we go. A little bit trickier. Let's try to find x first. Thank you kindly. So x is in the expression 2x minus 50. That's that angle right there. And thoughts? It corresponds to angle n. All right, guys, catch this. So this one's definitely got multi-step. This is actually a good problem to do. So let's do try sum for this, so don't throw things. I know all of these add up to 180 degrees. So let's find measure of angle n, which is equal to the measure of angle u, which will then equal that. So I'm going to say measure angle ny plus 24 plus 142. Man, it's a good thing I've got this pop screen on my microphone. So measure angle n plus 166 equals 180. Measure angle n is equal to 14. That's what I would have said, but if it was 160, it would have been 20. And so it's less. But yeah, I always have to double check those as well. So 14 degrees. So now, yeah, 2x minus 50 equals the 14. I get x is 36. And they just wanted the value of x and y. Also, with the save. Man, Mr. Waddy's making errors today. Hey, it happens. So, now that I know x, I think I can find y. I think I can find y. So I know that NP has a measure of 2x minus y meters. NP corresponds to us right there, which is 13. So I'm going to say 2x minus y equals 13. I could plug in 32 right there. And 2 times 32 minus y equals 13. I love the color combination when I do substitution. Are you guys fans of that? I love it. How about you, gentlemen, in the front? All right, subtract 64 from both sides. That's going to be negative 51. And then opposite both sides, y equals 51. Yikes. All right. That is a tough problem. That was basically a system of equations from Chapter 5 in your Algebra 1 days. So the geometry only happens right here and here and here, and then the rest of it was algebra. So you got to be sharp with your algebra skills here, friends. Oh, I was using the fact that the corresponding parts of congruent figures were congruent in order to make those claims. This was try sum, and then I knew that this angle and that angle were congruent. So yeah, here we go. How do I say y in French? Y. Man, I might name my fifth child Y. All right. I'm not planning on having any more kids, and now that it's on the internet, it's official, right? Anytime my wife asks, I'll just forward her this video with a timestamp and be like, I can't lie on the internet. So here we go. Show that the polygons are congruent. I'm going to make a whole bunch of claims, and then we'll see what we can do. So in order to prove congruence, at this point, our only ability to do so is to show all corresponding parts are congruent. So let's see. Right now, I've got segment, 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 segment. I need to show that the third side of these triangles are congruent. Can I show WY is congruent to itself? It's always congruent to itself. Why is it congruent to itself? which is called the reflexive property. All right. Fumble. All right. So, all right. As far as angles go, I know that this angle is congruent to that one. Is there a way to show other angles congruent? Thoughts? All right. So a student just noticed alternate interior angles theorem, which can be applied when I have parallel lines cut by a transversal. So which angles can I match up here? Oh, X, Y, W. All right, catch this, friends. Catch this. X, Y, W, and Z, W, Y are congruent by alternate interior angles theorem, right? Do you guys all see that alternate interior angles, this line, and whoosh, right? Cut by a transversal, alt ints. Are you seeing it? Are you seeing it, friends? All right. And angle X, W, Y is congruent. Hey guys, catch this. I'm worried a lot of you aren't learning or paying attention right now, and you're sabotaging your own education. Try not to. Yeah. So alternate interior angles theorem. So I've just shown all of the corresponding parts. All three sides, all three angles are congruent. Now I can finally say the following. I'll say triangle X, Y, W. And I could have picked any of the 6 combinations of combining those 3 letters. But now that I've made a choice, I have to match it up in the correct order for the other friend. So X corresponded to Z, so it's got to start with Z. Y, let's see, X, Y, W, so I think it's Z, W, Y. Yeah. Yeah. And the reason I can say those are congruent is this. Corresponding parts of congruent figures are congruent. But don't worry, we're going to practice some more with that idea later. Question, comment? Yep. So because those were parallel, that's why I was able to use the alternate interior angles. Parallelity won't prove congruence, but in this case, it helped me prove angles that were congruent to each other, which is what I did need. Today, in today's lesson, we're learning about the side angle side congruence theorem, in which instead of showing all 6 parts of 2 triangles as being congruent, I'm trying to find a more efficient way of proving congruence, and that's what we'll be doing today. Foreshadowing. All right. So guys, hey, check this out now. Third angle theorem. If I have 2 angles in one triangle congruent to 2 angles in another triangle, then the remaining angles are congruent. So I could say angle C is congruent to angle 1 by third angles theorem, TAT. And then I can use trisum to find the measure of angle C. I know that these 3 angles add up to hundo ate. So I could say measure angle Charlie plus 45 plus 80 equals 180. So this is true by trisum, which you didn't have to write all these down, but it's not a bad idea for us to practice the names of these things, so we'll be more familiar with them later on. So let's see, measure angle Charlie. Let's see how well I'm good at the adding. 125? All right, and then subtract 125 from both sides, I get 55 degrees. And if measure angle Charlie is 55 degrees, then I can def Kong and throw that in for angle 1 substitution style. Right? Yeah. So measure angle 1 is also 55 degrees. You didn't need to show all of the work. I just want you to know why the work works. All right. Do I have one more problem? Is it the proof? Yeah! Here we go. Triangular postage stamps, like the one shown, are highly valued by stamp collectors. Prove that these triangles are congruent. Yeah. So I've got my given information, donezo. We know how to do that. All right. So the given information looks like most of it's labeled. They then say AEB is congruent to CED. Let's where that is. See where that is. AEB is congruent to CED. Why do you think those angles are congruent? vertical angles theorem. So look out, our old theorems are all still able to come into play. All right, as well as our old definitions, which I think is going to help us on this next claim. It says E is the midpoint of these two. I think I could use that fact to claim... No, not that. Never mind. That one's coming up right here. I technically could have done that in a different order. Tell you what, I'm already here. AE is congruent to EC, or CE, and BE is congruent, let me trip mark that, to DE. Why are these true based on this fact? If E is the midpoint of those bigger segments, then it divides the segments in half. That is def of midpoint, right? It's just applying the definition. So properties, postulates, theorems, definitions, corollaries, all of these are fair game in our toolbox in order to prove things congruent or lines parallel, whatever we're doing. I mean, that's technically why I've got the little spell books for us that hopefully we'll be able to access, right? Everything we need to know simultaneously. All right, here we go. Angle Bay, what? Right here is congruent to angle DCE, right there. Anyone see why that might be true? Alternate interior angles, because that's some parallel lines right up there. So IT, and that's also true why ABE is congruent to CDE. And so that's all of that. That's all 6 parts of these figures, and therefore the figures are congruent by all corresponding parts are congruent, which I'll also allow corresponding parts of congruent figures are congruent. Section 5.7 will be a similar theorem called CPC-TC, in which it won't just apply to figures, it'll be only talking about triangles. All right, well, thanks for watching, Internet friends. Have a great day. Bye.